Click the bell icon to get latest videos from Ekeeda.
Hello friends, today we are going to discuss about the types of scheduling queues, how they are implemented and what their CPU usages and termination of the process will affect the queues, etc. As a process enters the system, it may be spooled into a mass storage called a job queue. This job queue has all the processes remaining. Now the processes that reside in the main memory and are waiting and ready to be executed is known to be in a list called the ready queue. This ready queue is implemented acting as a linked list. The linked list containing all the processes, the header and the tailor, the PCBs. The header of this linked list contains the first and final PCB in that list. And every PCB has a pointer that points to the next PCB in that ready queue. So it diagrams in this way. As we can see that the last PCB in this ready queue is pointing to null as no other processes are waiting in the ready queue. Now along with this job queue and ready queue, there are many other queues according to the scheduling of the processes. When a process is allocated with the CPU, it executes for a while and then it can quit, it can be in the background, or it can goes with the IO event waiting and completion of the IO event. After that it can resume its operation. So suppose that a process is requested for an IO device, say disk, and there are many other processes on the multi-user and multi-programming system waiting for that IO device disk. And maybe happen that the CPU is busy with other tasks and the IO device is used by some other process. So the process now has to wait for the IO to complete its operation on another process, and then the IO device can be allocated to it. So all the processes that are waiting to some IO devices are put into the device queue. This device queue contains the processes which are waiting for disk, memory, and IO devices. A new process is first put into the ready queue, then it is awaiting the execution or dispatch to the CPU scheduler. Then it is put into the ready queue. From the ready queue, it is moved from the execution pointer to finish its executions. Now we will see with the queuing diagram, which will use rectangle as the queues, circles as the resources, and arrows as the flows between these resources. First the job is put into the ready queue. Then if it is allocated the CPU, then it can start its execution. Now as the CPU is dispatched, the following events can occur for a process. So the process is requesting for some IO and then it is putting in the IO queue. As the devices are not available and used by some other processes, then the process has to wait for some IO devices to occupy and freed its memory. So it is first the IO request is done and then it is putting in the IO. After the IO completion is there, then the process can resume its operation. The next event is the process is spawning a new process and then it has to wait for the new process to terminate to again resume its operation. The next event is that the process is forcibly removed from the CPU due to an occurrence of an interrupt or the process has terminated its execution. So to occurrence of an interrupt, the interrupt must be serviced to resume the process's operation. The last case is that the process is waiting for some other time and the process time slice has expired, so it has to be in the ready queue again to resume its operation. As we can see, in the first two cases, the process are from the waiting state moved to the ready state and then put back to the ready queue. In other cases, all are back to the ready queue to resume the process's operation. So after the process has finished its execution, so all the PCBs, the resources are delocated and the process is terminated, removed from all the queues. So that is all for the scheduling queues. Thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda.